guys. Welcome to the School of Statistics and Data Science, and let's start solving some great problems on testing a hypothesis that we have given an assignment in the Platinum course. So let's start one by one. Okay, so fine, just give me a minute. So I hope it's clearer, but let's do it today again. These are some other problems from name and Pearson lemma. So I think this week is the last class. Like we are ending this week we have ended almost all the topics of or the entire syllabus. From the next week we'll be discussing just problems and just problem solving of past years and some interesting problems that we have on our mind. So. Coming back to this problem, I hope you can see the problem on the board, guys. So find the Neyman Pearson lemma of size alpha of the test theta is equal to theta naught versus theta is equal to theta 1, where theta is this will be less than theta naught based on one sample size, just one sample size. Okay, so if you base on that one sample size, so do you want to volunteer, guys? Anyone? Nikhil, Rajesh, and or Shana, anyone who wants to volunteer the steps, how to do it? What is step number one?
We have to write the likelihood or joint distribution.
Yes, so write the likelihood of what? So you didn't tell it fully clearly, that's why I'm asking again.
Like likelihood under H1 divided by likelihood under H0.
Very good. So that is important. So you need to first find the likelihood of under H naught. By likelihood under H1. Sorry, the opposite one. So let's find out likelihood under H1 and likelihood under H naught. Step 2 is step 1 is H1, step 2 is H naught, and divide it. So let's write it down. Here is just one sample over here. So you just need to do the you just need to do this one sample, just x is over this. Just keep it x, okay? That is doable, yes. So therefore under H1 is theta 1. So it's 2 theta 1 x plus 2 1 minus theta 1 1 minus x. And here it's 2 theta naught x plus twice 1 minus theta naught 1 minus x. Okay, and what is the step 3 now, guys? What's the step 3? Yeah, tell me what is the step 3? Divide them and see, you will not get this opportunity to discuss one-to-one with me because the class strength may increase. So use the opportunity to discuss with me live, if possible, like unmuting yourself.
Like we divide them and we reject them when it is greater than some k.
Okay, good. So we divide them and so let's call it L1, let's call it L2, L0. So L1 by L0. So we rejected it with the greater than some k. Perfect. So it's a rejection region. This is the rejection region R. So let's write it down properly. So we need to write it down properly, clean it, and cleaning it, write it down will lead to twice theta 1 x plus twice 1 minus theta 1 1 minus x by twice theta naught x plus twice 1 minus theta naught into 1 minus x is greater than k, right? It's very easy, and you can understand that 2 is getting cancelled over here, so you get theta x. Let's expand it in some sense, and plus 2 into. So can you just calculate the upper hand, please? The denominator and the numerator, please.
Sir, if you're canceling two, then there will be no two left in the anywhere. So
Yeah.
it will
So
be there.
yes. So can you just tell me the final output upar wala? Like what is this? If you output this, it turns out to be theta x, 2 times theta x plus 1 plus theta x minus theta minus x. So it's theta twice theta x plus 1 minus theta 1x minus theta 1 minus x by twice theta naught x plus 1 minus theta naught minus x is greater than k.
Sir, two will not be there.
No, this the 2 theta x now.
Oh, okay.
Yeah. So you get twice theta 1x plus 1 minus theta 1 minus x by twice theta naught x plus 1 minus theta naught minus x greater than some k, and for this k we have, so you can understand it now that we can subtract and add and do that stuff. We can subtract this, so, or we can just take it on the other hand side. Understand that the only variable here is the x, others are all constant. So make sure that you have that on your mind. Just make sure you have that on your mind, okay? So this is a bit long. You will see, we can also find out that this function maybe is increasing in x, but we can understand it from here only by calculating minus k theta naught minus kx. Okay, so you understand these are all constants. So you have to understand all these are constants, okay? Theta naught, theta 1s are all constant over here. Getting what I mean? So therefore understand this. This is constant, these are constant. Okay. This is constant. This is constant. So only x wala will matter. So we get that twice theta 1 minus k theta times x. Okay. It's greater than. Okay, there is something else also. So yeah. Actually x common laker twice theta 1 minus 1 over here and minus k over here and plus k. Something is wrong. Yes. Twice theta 1 minus 1 minus twice theta k plus k. Yes. Is greater than some constant. Let's say c. Okay. Did you understand till this point of time, guys? We are trying to.
That's no problem.
So now, therefore, what it turns out that we have to find that specific case. It turns out that x is greater than some c, but there's a problem over here. You can tell me what is the problem? x time this twice theta 1 minus twice k theta naught plus k. What is the problem? So this is a rejection region. So now, what will be the rejection region? That's my question is. What will be the rejection region now? Can you tell me what I'm trying to focus on?
Like we are trying to rejection region basically like it's of the form x greater than c. Like we are trying to see what form it
But
exactly
but
was.
but but it will only happen x greater than c if this is positive.
Yeah.
So you have to check if this is positive or not. So we have theta 1 greater than theta naught, theta 1 less than theta naught it will be. So if theta 1 less than theta naught, so understand that k is what? K should be, greater than 1. Like it should be greater than 1. Like it's like L1 is actually dominating more than L0. L1 is dominating more than L0, okay? That's why it's happening. And if L0 is dominating more than L1 is dominating more than L0, then only it will reject. So K must be greater than K, 1. But let's see whether this is positive or negative. So how do you see whether this is positive or negative? What is the way out? So anyways, for whatever values of theta, this is the relation region. So tell me, what do you think? This is becoming a bit more confusing. Yes. So depending upon what value of how the value of k is determining the output. What do you think, guys? Tell me.
Like we have already theta 1 is less than theta naught, so that the first term now again the two factors there, so that's complicating things, but the second one will be greater than 0.
The first one is less than 0, right?
Yeah, first one should be, yeah, since theta 1 less than theta naught will be less than 0, but second one will be greater than 0 because k is greater than 1. So we don't know which one is overpowered. That's the problem.
That's a problem. That's a problem. So how do you manage this? How do you manage this? Tell me. Okay, let's say intuitively, what do you think? What do you think intuitively? Because you don't know about what is this theta. You understand the issue. Here you not don't know what is this theta, what is parameter theta indicates, right? You don't know that. Can you tell me intuitively what this means? What is a theta? What does theta tell you over here? So you can understand that f theta is nothing but twice theta x plus 1 minus theta minus x. So if you integrate that, or 0 to 1, it will
Sir,
be,
already theta is given between 0 and 1, so there is no problem, right?
I'm not getting you. Can you come again?
No, theta is given between 0 and 1, so like both theta 1 and theta naught, we have the bounds now, so there is no problem, I think.
No, I mean, yeah, see, why I'm telling you this. Dekho, if it was normal theta, okay, so you knew that it will be x less than certain c, right? If x is less than certain c, then you will reject it, right, Nikhil? Because you know the meaning of the parameter theta. You know the into c. Why I'm telling you? Because you know we have done a lot of mistakes a lot of times where we always do where, due to this small calculation errors, we just reverse the sign of the test. So what helps then? Then the intuition of the whole thing helps, right? The intuition of the, like, if it is normal, then the intuition helps. But here the issue is that we don't know the what does this theta, how is this theta the variance, is this theta related to mean, is theta related to the median, or the first order statistics? You don't know that, right? That's the main issue. That's why you're not being able to think that what will be the intuitive rejection region. Did you understand this point, guys? It's very important. So this is the difference between this problem and the other normal usual problems that you have done. Here it's an unknown PDF and you don't know the behavior of the parameter theta. What is theta? So tell me now. Tell me what you will do. Tell me what will you do now. So think about this equation. Think about let's think about this. See, I'm going to the very basic of it. Okay, how do you think? I mean, I'm not only giving you the way out, but also the intuitions. The intuitions are important. So here, fx of theta is what? Twice x. Okay, twice theta minus one minus, sorry, plus one minus theta. This is between x is between 0 and 1. Yeah. So let's integrate that. Let's find the, what does this mean? We don't know that. First of all, let's check whether this is a PDF or not. Valid PDF or not. Can you just check if it's a valid PDF or not by doing integration? It's turning out to be a valid PDF, right? It's turning out to be, right. It's turning out to be 1, so it's a valid PDF. So let's do the expectation. How is the theta related to the expectation? So why I'm doing this? Because I want to make you understand the meaning of the test that will turn out to be. Now we're trying to find a test of the theta. So what is this theta? We have to understand what does this theta determine. What is the meaning of this theta? Otherwise, the test will not be, it will just be a test, but we will not understand the meaning of the test. So the statistics is more than just prediction and making the rejection region. Also, there's another dimension of understanding what's going on. So let's find out what is this theta. So let's do the expectation. The expectation of x will turn out to be what? Integration 0 to 1. 2 will be outside. So twice theta minus 1 x square plus x plus 1 minus theta times x dx. So we do this, we get 2 cos theta minus 1 by 3 plus 1 minus theta times by 2, right? I hope all of you are understanding the ideas. Nikhil, Paulami, I don't know about Paulami because she came in late. Shana,
Yeah, like no problem.
Very good. So we have 4 theta minus 2 plus 3 minus 3 theta by 6. So it's turning out to be theta plus 1 by 3. So you can understand it's proportional to theta. So therefore, we will reject if x is less than that. Did you understand? Does it make sense now? Nikhil and China and Ptolemy. Does it make sense now that why will the test turn out to be that way? It could have been 1 minus theta, okay? Then it would have been x greater than c. So I understand the meaning, guys, what I'm trying to convey to you. How the
No,
parameter.
like this last part, it's proportional, yes, but what's happening to the rejection region then?
See, here what is turning out that expected value is proportional to theta. So it's like it's theta plus 1 by 3. That means the average, the sample mean, if it's less than that, less than a certain value, we will reject that, right? That actually what happened to normal, right? It was the normal theta comma 1. We reject if the sample mean was like, if it was like this, theta naught versus theta 1, which is less than theta naught. Then what we do, we reject if the sample mean is less than certain value, right? That's the idea, that's the basic idea. Because this is a good estimate of, like, theta is it's for normal theta comma 1. For then we do it. So here the mean is that it's theta plus 1 by 3, it's proportional to theta. So it's same thing, like, we replace theta by x bar plus 1. So we reject this if this is, like, less than c. That's the same thing, right? Like, we reject, therefore x bar must be less than certain c dash. Did you understand? Shana and Nikhil and Ptolemy.
Okay, got it.
Yeah. So what I'm telling you, what I'm going to convey to you is that the test what you get is more than, like, you should know more than it. Like, why it is important? Because it gives you a, when you're solving problem in the exam, it gives you, a solid proof. Okay, it matches my intuition, therefore it's right. My calculation is right.
Okay, so basically in this case, then the sign will get reversed, right?
No, it will be same. Oh, it will get reversed. It will get reversed. You're right. It will get reversed. You're right. So this must be less than 0. You're right. You're right. So you have to prove that this will get reversed. You understand now? So how to prove that? That's my question. So you see that if we could have done it greater than 0, you see, Nikhil, the idea and others, that here is what our intuition says. Oh, did I do a mistake? I guess. Wait, just let me think. No, I didn't do any mistake. You see how intuition is helping, because the intuition says the mean is proportional to theta, so we will reject if theta is x is less than certain c. So therefore, this must be less than c. This is the beauty. So therefore, let's understand this, that what happens to this 2 theta 1 minus 1 minus 2k theta naught plus k. We know that theta 1 less than theta naught less than 1 less than greater than 0. And we don't know anything about k, but it's expected k will be greater than 0. So we have to prove that this is less than 0. So how do we prove it? This is equivalent to this, right?
Yes, that's, and we have like theta
No, no,
naught and
sorry.
theta 1 will be
I did a mistake.
between 0 and 1, so
I did a mistake.
I think it's done.
No, I did a mistake. This is the idea. So we don't know whether this is less than 0 or not. So we need to have two cases. So you see that this is the case. And let me see the problem. This is the basic idea. And 2 theta 1 minus 1 is less than k. So this is a problem that can come in IIT. Okay, it's a very doable problem. So you see how it can be sometimes bit more involved. So 2 theta 1 minus 1 less than k less into times 2 theta naught minus 1. So now it depends like whether this is less than 0 or greater than 0. What do you think? So theta 1 is less than theta naught, right? Both are less than 1 or both are greater than 1, or at least 1 is greater than 1, or theta naught is less than 1 or theta naught is greater than 1. This something can happen. Okay, so if this is the case, so you have to take two cases where theta 1 less than theta naught less than theta 1 and theta naught greater than naught. If this is the case, we get twice theta 1 by twice this less than k. If this is the case, we get the opposite one. Okay, and you know that twice theta 1 minus 1 is, see, it's becoming much more complicated. So how do you do this problem now? So do you think it's always true? Do you think it's always true?
No, this is depending on the value of the where we are testing. So it's not true. Like it's a dependent test on the parameters. So that's the problem.
Okay, tell me this thing. Two theta 1, okay, what if I tell you mm, this is always greater than this, right? So what is the final thing? The final thing is that twice theta 1 minus 1 less than k times twice theta naught minus 1. This is coming out to be the thing, right? From this whole thing. So my question is that twice theta naught minus 1 is greater than twice theta 1 minus 1, right? So what if I tell you
No, it's actually reverse. Theta 1 is greater, right?
no, theta 1 is less? That
No,
is
theta 1 less than or greater than?
less.
Okay, less than.
Yes. So if this is the case, I personally think what is happening is that we need an extra condition over here. Mm, just give me a minute. Let me just check the question. Yeah. Okay, this is always true, right? If A is greater than B, this is always true. Now my question is that I multiply with it k and I multiply with it 1 because k is greater than 1 and k is positive. So 2 theta naught minus 1 or times k must be greater than this, right? If A is greater than B, A can be negative positive and there is a C greater than 1. Then AC is greater than B, right?
Yeah, so I don't. Yeah, so this can.
This is true. And this is basic mathematics going on. And so I'm not telling anything hard. And why k is greater than 1? That's what the intuition is. If k is not greater than 1, like then k must be less than 1. That means h naught ka likelihood is more than h1 ka likelihood, which is not true. So k must be greater than 1 because we are rejecting. That's the basic idea. K must be greater than 1. You see, the C must be greater than 1. Otherwise, will not. This must be greater than 1. Otherwise, we will not reject it, right? Does it make sense? If the likelihood is less than 1, like the likelihood of H0 is greater than likelihood of H1, why will I reject H1, H0? We'll only reject if likelihood of H1 is greater than some something more than likelihood of H0, right? So K must be greater than 1. So this is the intuition you must be using. See, the problems are more than mathematics. It's also about intuition, guys. Are you understanding? This is very, very important in statistics. Did you understand, guys?
Yeah,
Shana, Nikhil,
good.
Paulini,
Yes.
very good. So this is a very beautiful problem. This can come in the exam hall. And you see, many people will get stuck in this step because they will not know what to do. Intelligent guys, they will not even create this step. They will not even look into this step. What they will do, they will calculate the mean. And they will see, okay, x is proportional to the mean. So therefore, we'll only reject if x is less than c. Did you understand, guys? This is how your intuition can help you a lot in understanding a problem. Did you understand, guys? Right, a boom.
Yeah, so like final answer of this problem, what is like expected? What's the final thing?
Oh, the rejection region is x less than c. Now you can find out the probability. You integrate over this under h naught, and you can find out equal to alpha. Do you have to do that step? I think that you can do. Do you have to do that step? Will I need to complete that? What do you think? Do you want me to do it, Nikhil, Shana, Prolimi?
Like no, like just write the equation
Yeah,
and
sure,
they
sure.
can do
So
the
we have
rest.
understood that the rejection region is what? R is of the form x less than c. So now we have to find a level alpha. So that means what? Probability under h naught, a rejection region. That is probability under h naught, that is theta is equal to theta naught, x less than c. That means integration 0 to c twice that stuff, the PDF dx is equal to alpha. That's the level alpha test. And you usually to find out c. And you get the rejection region. Right? Did you understand, Nikhil? Yes or no?
Yeah, okay.
So are you facing problem in this step, Nikhil?
Yeah, usually what happens, like that's my main problem. Like you start with it, and by the end, the solving part, that's the place sometimes I get stuck.
See, I will repeat once again. What happens? Step one, you find out the rejection region in terms of by likelihood by like the two ways out. One is the NP name and Pearson lemma, or is the likelihood ratio test by any one LRT, or just it is mentioned, just mentioned. Any of this way, you first find out the rejection region in terms of C, that constant C. After that, you get you probability on H naught R C is alpha. That is the level alpha, size alpha. From that you find out C, and that turns out to be the fixed rejection region based on alpha. And then once you find the reaction region, you can find out the power. Did you understand, Nikhil?
Yeah, got it.
So don't forget, this is very easy, okay? I mean, this is very, you solve more problems, you will get used to it. Okay, let's move to the next problem. This is a really beautiful problem. So you need to understand the problem, okay? More than like, more. So let's do this problem. In each of the following simple versus simple hypothesis, x f naught, I will just do one of them. Find out the form of the Neyman Pearson test. Okay. Find out the problem of the Neyman Pearson test. Find out the form, the rejection region. Okay, with less than c. So what it's trying to make you understand is the following, that this lambda x, that is L1 or F1 or L1 x by L naught x, which is your F1 x by F naught x, this is greater than c. Okay, this is the rejection criteria, right? RC. So they are trying to tell you is that it's a mathematics problem. They are trying to write it in the terms of such that x belong to some set in that format. Okay, that because that will be easier to compute, right, guys? Here previously it was x greater than c, so it was easier to compute. Similarly, here it will be easier to compute. So when you try to find it in terms of this, so let's do one example, guys. Okay, so tell me which one you want me to do, A, B, or C. Shana, what do you want, A, B, or C? Quickly.
Yeah, let's do B, like with both elements.
Okay, let's do B. Very good. So half exponential mod x. So let's write it down. So you see the always do with a constant, some constant here. So it's 1 by 1 plus x square mostly. That constant is taken out and it's half exponential minus mod x. Okay. So this must be greater than some c. So what is this? Some k positive times 1 by 1 plus x square by exponential mod x is greater than c. Can you just tell me what is this? So you can write it as k times 1 plus mod x whole square into exponential mod x, and mod x is greater than 0. Can you tell me what this is? This is a decreasing function of mod x greater than c. You see, this is decreasing. Since mod x greater than 0, this is decreasing, right? Because mod x is greater than 0, 1 plus x square, it's on the positive side, so it's increasing on the positive side. It's also increasing. Therefore, it's
Sir, what happened to that negative in the beginning then, the exponential minus mod x?
वो तो नीचे आ गया ना?
Sir, that was like, it's minus, okay, fine, got it.
Yeah. Okay, don't make me afraid. I am very bad at calculation mistakes. So therefore, this is a decreasing function in mod x. Therefore, what happens? If this is decreasing function, therefore, we'll only reject if mod x is less than c. See, decreasing function just opposites the sign. Okay, decreasing function means what? If this is greater than this, then that is the sign opposite. So therefore, we reject if this happens. Did you understand the rejection region, guys? Did you understand?
So like I have some problem with this, like when it is a decreasing function, why do we reverse the sign?
Oh, what is the definition of a decreasing function? If a is greater than b, then fa is less than fb, and vice versa. So here, if f decreasing of mod x 1, so therefore if f decreasing of mod x is less than c, or it was what, greater than c, then what will happen? So we can get this by f inverse, right? So f inverse of f that will be, so ये greater than है, so ये ऊपर, like if you can also write this like this. If a is greater than b, then fa is this. So this is less than some f inverse of c, which is some c dash, and this is nothing but mod x. Did you understand?
Yes. That e to the power minus of mod x was in the denominator, no?
No, dara. Oh, right. Yes. Oh, I have done a terrible mistake. Thank you, Polemy. Okay. So I have done this mistake. So let's. So yeah. So it is opposite. I have done this mistake. So it's exponential minus mod x, because it was below, is greater than c. So therefore it will turn out to some k times exponential mod x by 1 plus x square greater than c. So now it's a bit of a problem. This is increasing and this is decreasing. Okay. Now what you have to do? Now what you have to do? You see, when you divide it by this, the exponential goes above, right? So now what will you do? Tell me. So let's see if x is a bound or not. X has no bound. So you have to plot it now. Otherwise, there is no other way out. You have to plot it. You have to plot exponential mod x. So therefore, this means what? It's exponential x. So it is e to the power x by 1 plus x square. Here it's e to the power x. So for x greater than 0. Okay. And here it's e to the power minus x by 1 plus x square for x less than 0. So draw e to the power x by 1 plus x square. You have to draw that function, otherwise there is no other way out. So you have to really draw that function. So let's try to understand. E to the power x is like this, and 1 plus x square is like this. E to the power minus x is like this. E to the power minus x, e to the power x, and so these are hard problems, and you have to do this. So here, left hand side for x less than 0 is e to the power minus x by 1 plus x square. And here is e to the power x by 1. So it's some, it's an even function. You can understand it. It's an even function. Okay, it's an even function. You can easily understand that. So the question is that how the whole thing happens. That's the main question. How the entire thing happens. We know this goes up. So my belief is that, so you can also know, my belief is that it will go like this. At x equals 0, it's both 1. So initially it decreases and then it increases. Here also it's initially decreases and increases. This is my opinion. Yes. So let's draw the function then. Just give me a minute. So this is a bit hard in the exam hall, and also this type of questions may not come. But my thing is that we should make it like, otherwise it will take some time. We have to differentiate it, and just give me a minute. A1 plus 6.
Means as e to the power of mod x is in the numerator, then as x increases, then the numerator will increase more rapidly than denominator. So increasing function like this or something.
Yes, as I have guessed, it is like this. Is it increasing? Yes, it's turning out to be increasing. That's good, actually. Wow. Okay, that's good. It's turning out to be increasing, and it's a very beautiful function. It looks beautiful. So yeah, you can also find out whether it's increasing or not. It's turned out to be increasing. So as I have guessed, almost it will be like that, but it's not decreasing, it's increasing. So it's turning out to be that way.
Yeah, but how to guess that this will be this graph and not the one
Usually
you
what
have
happens?
drawn?
Yeah, yeah.
Because if the one you have drawn, then we have to see the inequality when it is decreasing, when increasing, and all.
That's why you have to use calculus here. So it's an odd function, so you just look on the right hand side. E to the power x by 1 plus x square. So what do we have to do? F dash of x. So I just try to avoid it because it will create more time, but I have to do it. I have to see anyway. Say f dash of x. If you do f dash of x, can you just tell me f dash of x? It's u by v format. So it's like, can you just tell me what is this u by v format ka? So e to the power x का क्या था? Yeah, tell me. E to the power x का e to the power x into fx is e to the power x plus 1 times, yes, 1 times, sorry, e to the power x plus this plus that whole, so it's minus 1 by whole square 2x, ऐसा कुछ आएगा, I guess. So it turns out yeah, so this is the idea. This times 1 minus x whole square, it will coming out. See? So you can understand this is greater than 0. And at x is equal to 1, it's turning out to be greater than equal to 0. Okay? And x equal to 0, it's turning out to be 0. So therefore, it's increasing. Did you understand? It's increasing, non-decreasing. And x equal to 1, it's what happening is that it's the point of inflection is coming. Did you understand, guys? How beautiful the problem is? Did you understand why this is happening? So it's increasing. F dash x is greater than equal to 0. So therefore, it's non-decreasing. Therefore, it's a non-decreasing function of x. So this is equivalent to greater than c is if and only if x is greater than c. You see how, yeah, you see the whole thing, guys? Did you understand, all of you? Did you understand the graph?
Yeah, I got it.
So these questions are really beautiful and really informative. How this greater than 0, like, it depends upon the function. You need to know calculus over here. Shaya, did you understand? Okay.
Yes, sir.
Okay, what about Ptolemy?
Means here we are considering only x greater than 0 because
Oh, okay. So that's a good question. So to understand the function, we are considering x greater than 0 because it will be just reflection. It's an even function, right? it will be just reflection on the other hand side. So therefore x greater than c is always greater than 0. So therefore understand this, since c is always greater than 0, so this is the fx, this is the lambda x. Okay, now this is greater than 0, greater than c. Now let's say the c is turning out to be this point. So what happens? How does the x looks like? Oh, sorry, I have I have done something wrong. Thank you for telling this. It will be mod x greater than 0. Mod x greater than c, not x greater than c. Yes, thank you. It will be mod x greater than
Yes.
c. So this greater than c will turn out to be x greater than c part and x less than minus c part. It's an increasing function in mod x, not x. It's an increasing function in mod x. So therefore, for x greater than c, this is this. For x less than c, this is minus this. Since it's even. Did you understand, guys? So therefore, the rejection region is of the form mod x greater than c. That is the rejection region. And now, Nikhil, I hope we can do this. This is a rejection region idea. Okay, did you understand, Shaina and Nikhil? Follow me, did you understand? Thank you for the doubt, like, asking that stuff. You see, again, the idea of this, this idea of rejection region, I just did x greater than c. This wouldn't have been the problem if we knew the parameter ka stuff, which is not here though. But this idea of this intuition is not available over here. It's a bit, non-available over here. But we can say something about it. You know how? Can you tell me how we can say something about it? Like, which one to accept when? Can someone tell me that? Let's explore that, okay? Let's see which one to accept when. Okay, this is very important. How will you logically, how will you intuitively know that we will reject this one when mod x is greater than c? Can someone logically tell me, like intuitively? So we have two equations. F naught is half exponential mod x. The question is that, and f1 is 1 by pi 1 by 1 plus x square. The question is that we are rejecting f naught if mod x is greater than c. The question is why? Can someone tell me this? Can tell me what are these two distributions? Can someone, because these are intuitions, okay? You should be having some
Yeah, first one is
Laplace.
Laplace or double exponential, and second one is Cauchy.
Cauchy. So to understand this, what do we do? What? So can someone tell? This is a very interesting question. This can be a very good interview question, I guess, for any job interview for data analyst. So can you tell me like what is going behind the scene? It's an intuition, okay? Why we're rejecting if mod x is greater than c? It's a very beautiful problem. Okay, I will draw the graphs now. I will draw the PDFs, okay? Laplace distribution PDF. You will now instantly see. So these are very important questions, guys. You always ask why. Otherwise, you don't develop. Like this why will not come in IIT, okay? But you should understand that for your own understanding. Like why we're rejecting this? What is the what is going on? So this is the distribution of Laplace. I think we are a better one. Just give me a minute. It's all about PDF, okay? It's all about PDF, guys. It's all about PDF. You will understand. It's all about probability. This is Laplace. This is the beauty of all the whole thing. So let's do Cauchy now. Just Cauchy 01 over here. Okay, just give me a minute. I think it's Cauchy 01. This is something called heavy tail distribution. You will understand. Let's put it over here. Okay. The YOLO or the this one, the purple one. Can you tell me like why we're rejecting this? Why we are rejecting when mod x is greater than thing? It's a very interesting problem. So we have this two distribution. We know the data is coming from, there is one data which is coming from one of this. So observing the data, we will know that if mod x is greater than c, we are rejecting that it's from Laplace of certain c. That is, if mod x is really, really large, it must be from Cauchy. Can someone tell me why? This is a very beautiful problem. Can you tell me why? It's very
So
easy.
basically, we are going to add final thing. We are going to see the probability. So if the like if it's heavy tailed, there'll be less probability. Like it'll be less spread, and if it's light tailed, there'll be like more. Like there'll be more spreading at the side. It'll be more wide. So yeah, that's we have to see the graph and tell. That's what
Okay,
it is.
okay, but you don't know, like, from this two the graph, you cannot tell it here. Can you tell it any other way that we rejected if mod x is greater than c? Any other way? You know it?
Sir, but this is both like this is standard Laplace and standard Cauchy. So we already have the parameters. So there's only one particular two graphs that we have to look.
Yeah, that's true. But my question is that how to understand? Like, you cannot understand from this graph, right? It's not understandable from this graph. What is another logic out there? How will you know that Cauchy is much more heavy tailed than Laplace? Just one line answer. Very easy, Bolo. What is something very interesting about Cauchy? When do we give Cauchy as an example?
Like there's no expectation. It doesn't exist. That's like the significance mainly. It doesn't help you.
Okay, what if I take like, do you know like expectation of mod x for Cauchy, and what is expression of mod x for Cauchy? Bolo? What is expression of mod x of Cauchy? It's infinity.
So basically, it's
Oh,
the
I'm so sorry.
problem
I'm
is
sorry.
it's
Sorry.
not
Wait, 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 wait.
finite. It goes
I'm
to
sorry. I'm
infinity.
sorry. It's not infinity. I'm sorry. This is something I have told wrong. Expression of mod x of Cauchy is not infinity. Just give me a minute. It's not infinity. Just give me a minute, okay? But expectation of x square is infinity. Do you know that for Cauchy? The variance is infinity. Mod x is not most probably infinity, as far as I remember. But do you know that Cauchy has infinite variance? Hmm? Cauchy has infinite variance. Cauchy distribution, standard Cauchy has infinite variance. You can just calculate that. Just give me a minute. If mod Cauchy ka is, just give me a minute. is mod Kochika expectation is what? Also find out mod Kochika expectation. As far as logically it should it be infinity. But anyways, we know that the variance of Cauchy is infinity. Okay, so what does it tell you? It tells you that it's much more varied on the tail than exponential. जिसका variance is what? Laplace का variance is finite. That means Cauchy is taking much more probability on the tail. That's why we reject, which is not in Laplace. Therefore, we reject if not only if there is much more probability in the tail. X is on the higher side. Do you understand the idea, the connection, guys? Do you understand?
Yeah.
This is very important. So you see, this is very important. This is very understanding these things are very important. Questioning these things are very important. Okay, not just not doing the solve these problems. Now your homework is to go back and think about these ones when we reject it. Can you just tell me when we reject it? It's very easy now. Can you just tell me without calculation? Let's do this. Can you tell me without calculation when we reject this one and this one? When we reject f naught, can you tell me? It's very easy, guys. Just looking at the problem, can you just tell me? It's like shifted double exponential, shifted Laplace. So when we reject it, this has location -1, this has location 1. So when we reject f naught, bolo, when the value is very easy. When we reject x naught, so let's draw this. Always draw this, okay? This is -1, this is 1. This is, yeah, bolo. This is f naught, this is f1. So when we reject x, when we reject f naught, when x is
Greater than something.
so the reaction region will be greater than something. Very good. That's the idea. Let's talk about this one. This one. Sorry. What will be this? Bolo. What does this plus x and minus x? Okay, did you understand this one? The first one, guys?
First one okay, like but the second case greater y is greater than c, x greater than c. That
First one means you telling about this one.
yeah, this one,
I
this
told about
yeah,
A.
this one is fine. Now this a part I'm talking about, like the shifted Laplace.
Yeah, so this is f naught, this is f1, right? So it's telling that if you have a data, when can you surely tell it's from f1? Tell me.
Yeah, okay, fine. So then
That's the idea
then
of
for
rejection,
the
right?
third case
You reject something when you are almost sure that that is from the other side. It's like clustering. If you know clustering machine learning, you know, like it's more towards this cluster of f1 than the cluster of f0. That's why I told like this is a very good interview question. Okay. Yeah. Did you understand, Nikhil and others?
yeah.
Very good. And let's talk about this. How do you think about this? What do you think about this? Tell me. What do you think about this? What does this mean? It's very easy.
Same thing will happen.
Same thing, very good. Same thing. One ka location is this, another ka location is that. That's it. 1 and -1. So you reject f1 if x is greater than c. Do you understand the idea? This is a very beautiful one. So as you understand, in the exam, you also see that things will come up so naturally to you. You don't have to calculate the whole thing. You will know that I will reject when this is greater than this. You will just know from the problem only. That's how you reduce your problem solving time. because you know it better than others. Did you understand this, guys? Did you understand this?
So,
Yeah.
so can we say like for B, the location is 0 and so it depends on scale parameter. And for A and C, it depends on location.
No, this depends on location, but doesn't depend on skill parameter. It depends on the heavy tail, like the probability of Kochi being on more on the tail is much more than that of the exponential. Okay,
Okay, sorry, got it.
so that's why that's why when there is a number, you see that let me just plot it. Just you will understand it instantly. We plot this stuff. So one is exponential x mod x minus mod x, sorry. Another is 1 divided by pi times 1 plus x square. You will now see how heavy tail it is, so much heavy tail. So if you observe it, the red one is exponential mod x minus. This one is 1 by pi, that stuff. You can easily understand that the sum of the blue line and the area under the curve of the blue line and the red line are same. So therefore, after this region, this blue part has to sort of make up for this extra part. That means after this region, when the blue line goes over the red part, this is covering this, much more spreading out. So therefore, the probability of the blue line, the exponent, the Cauchy part on the other hand side is much more. While, so that means the probability of exponential, like for Laplace, it is much more concentrated around 0. For this one, for Cauchy, it is much more concentrated in the tails. That's why we reject a value from the Laplace if and only if x is greater. You understand? Because the probability of x coming from Laplace on the higher side is lesser, much lesser. For this, it is higher. Did you understand, guys? Do you understand? Are you understanding the idea?
Yes, sir, clear.
Very good. This is something you should be understanding. Like this is something you should be asking. Very good. Yes. So let's move to something different. Just give me a minute. Okay, let's do this. So we'll just do it, this is the problem I will end with. So we'll just do it with our intuition, okay? And you will prove it by NP lemma. So this is an exponential. So now tell me, what will be the reaction region? What is this theta? Can you just tell me? What does this theta denote? Without doing any calculation, can you tell me? So Shana just told about this कुछ देर पहले.
Theta here is the same.
Perfect. So how will it just give me a minute. Okay, so right. So let's see. I will end this with a blast. So you will see how the whole thing happens actually. So you don't have to use any kind of, like, sometimes you just have to use your intuition much more. Your brain is much more powerful. So I will just end with this. So you will see, can you see the screen, guys? This is the exponential, the Laplace. So let's observe. This is C, we are increasing C. This is C is theta, okay? C is only theta. You want theta? Yeah, this theta over here. Okay. So theta is not happening anyways. Let's call it C only. So observe what is happening when C is increasing. Can someone tell me? What is happening when C is increasing? The theta, right? Theta, it's like it was theta is equal to theta naught versus theta greater than theta naught. Like theta is equal to theta 1, which is greater than theta naught. So when will you reject? It's the same thing like we have done for Cauchy and exponential, right? Double exponential. Can you tell me? When will you reject this? So let's say versus this versus this. What is the difference?
That heavy tailed one
Very good.
means
Heavy tail one. Perfect.
the same rejection region will be.
Mod x greater than C, right? So that will be rejection region. You can do NP test and you can prove it. So that's your homework for today. You do it by NP test and show it's mod x greater than C is a rejection region if it's theta 1 greater than theta naught. This is the theta 1 greater than theta naught? Yes. Theta 1 greater than theta naught is the thing. So therefore theta 1, the more the theta 1 is, the more heavy tail it is. The more heavy tail it is, that means we will reject if mod x greater than C. So prove it that for it rejects if mod x greater than C. Prove it by NP lemma, okay? And submit it in the group, okay? In the platinum group. I hope you like this, guys, like this new idea of intuition and matching intuition with the whole thing. And it actually helps a lot. It actually helps you correct the rejection region. Also, helps you not do the steps in between. So it's important for you to understand. Okay. So thank you, guys, and I hope you enjoyed the class. And a very good.
But in the question, it was MP test.
Most powerful
MP.
test, right?
Okay.
Like, what is your doubt, Paulavi? Tell me.
No, you asked to solve it by NP lemma. So
NP
yeah,
test.
after that we have to find the size. We have to include the size thing.
Yeah. So if you know the rejection region of the form x greater than C, okay. Here it will be summation of mod xi. So you just do it for one of them and you add it all up. That's the idea. So it's summation of mod xi. So it's mod x greater than C. If that is the idea, then that is the RC. That is the RC. Then you find the probability of RC under each knot, which equal to alpha. Then you get the value of C. Right. That's the idea.
yes.
Did you understand, all of you? Nikhil, Paulami, Rajesh, Shana. It's very important. Thank you, Shana. Very good. So I hope you understood this. This intuition is super important, guys, and this can help you a lot of time. And this is the basic beauty of statistics, okay, and probability. Now you're understanding. Okay, it helps you, do stuff really quickly if you know it well. Okay, so good night, guys, and I will